Think, wonder. C. Human produces a lightning bolt. Duration of the lightning is 4 seconds. Think, how much power in a bolt of lightning? What kind of food and how much Miss Storm should eat to gain such amount of energy? Wonder, what is the possible size of your stomach? What should be a height of Miss Storm based on the measurements with the proportion of the stomach size? How much time she should spend to eat the needed amount of burgers in order to generate 4-second lightning? How many other kind of food, for example oranges, can contain the stomach of Miss Storm? Think, super energy. Storm is an extremely powerful hero and demonstrates a plethora of abilities, most of which are facets of her power to control the weather. Storm possesses the psionic ability to control all forms of weather over vast areas. She can control the temperature of the environment, control all forms of precipitation, humidity and moisture at a molecular level, has demonstrated an excellent control over atmospheric pressure and generate lightning bolts and other electromagnetic atmospheric phenomena. Refer to the citation 2 in a classic superhero conundrum. Where do these people get the energy to perform their superhuman feats? How Storm is able to generate bolt of lightning at her will? The goal of my work. Storm looks like a normal woman, quite pretty and skinny. I will try to investigate likelihood of production of energy for a lightning bolt by a human body, what was colorfully shown in X-Men movie. Super energy assumptions. In nature, lightning bolts carry from 5 kA to 200 kA, and voltages vary from 40 kilowatts to 120 kilowatts. Citation taken from 7. During the X-Men movie, Storm demonstrated many sessions of lightning bolt productions. Some of them were really long and intensive. For my investigation, I considered an episode with an average duration of lightning and let's assume with an average power. Calculating a 4-second lightning energy. If we take some averages, say 100 kA and 100 kilowatts, this bolt would carry this much power in the letter P. P equal to 100 multiplied by 10 in power of 3 ampere multiplied by 100 multiplied by 10 in power of 3 voltage, equal to 10,000 multiplied by 10 in power of 6 voltage ampere, or watts, equal to 1 multiplied by 10 in power of 10 watts. Recall that 10 in power of 10 watts is 10 billion watts! Whoa! Assume this energy is released in 1 second. Now convert electric power in watts, which is letter W, to energy in joules, which is letter J. The energy E in joules is equal to the power P in watts times the time period T in seconds, which is S. The formula is E, which is joules, equal to P, which is watts, multiplied by T, which is seconds. So joules equal to watts multiplied by seconds. For the example of our episode, what is the energy of a lightning bolt of watts for a time duration of 4 seconds? E, in joules, equal to 10 in power of 10 watts multiplied by 4 seconds, which is equal to 40 billion joules of energy! Whoa! Think, source of energy. What can provide Storm with energy? How much food should consume Storm to obtain the required amount of energy? Let's assume that Storm has a human body and human metabolism. Hence, the only source of energy for Storm is food. In order to calculate the quantity of food for Storm meal, I take in my research a food stuff highest in calories. The most common one is burger. The citation 5. Counting a number of burgers. How many burgers does Storm eat for her lunch to generate only one hit of 4 seconds lightning bolt? How much energy does consumption of one burger provide? This will be shown in my video, and all the calculations will be demonstrated. Have you expected that? 19,141 burgers! Only one meal! Whoa! And now I'm going to count circumference of my burger. Calculating a volume of burger. So now we are going to calculate the actual volume of a burger she is eating to create such amount of energy. The shape of burger is the same to an oblate flattened spheroid. The volume inside of an oblate flattened spheroid is V equal to 4p a squared c divided by 3, where V is volume of spheroid, A is the equatorial radius, C is the polar radius. In order to work out the equatorial radius, let's use the formula for the circumstance. The circumstance of any kind, a sphere, L is L equal to 2p r, where L is length of circumstance, r is the radius. For my burger, length of circumstance is 33 centimeters, which is length. Height is 5.5 centimeters, hence the polar radius is 2.75 centimeters, which is C. Then R equal to L divided by 2p. In our case, it's 33 divided by 2p equal to 5.25. Thus, the equatorial radius is 5.25 centimeters, A, which is A. So the volume of burger is V equal to 4 multiplied by p multiplied by 5.25 squared multiplied by 2.75 divided by 3. So volume of burger equal to 317 centimeters cubed. Hence, let's assume that volume of an average burger is around 317 milliliters. Refer to the citation 8. Wonder, a required volume of Storm's stomach. When we figure out what is the volume of one burger, we can estimate an approximate size of Storm's stomach, which has to hold the required number of burgers to be able to accumulate the needed energy for production of 4-second lightning bolt. Counting volume of Storm's stomach. In the following picture, you can see my calculations. And based on the result of my calculation, I figure out that the volume of Storm's stomach is 5,751 liters, rounding to 4 significant figures. Wonder, comparing sizes of stomach of human, our real creatures, and Storm. I also was interested to find out what is the capacity of different animal stomachs. So for cat it's 0.3 liters, for gorilla it's 2 liters, for cow it's 189 liters, for elephant it's 200 liters, for white shark it's 1900 liters, for blue whale it's 4000 liters, and for average human it's 1 liter. All these facts were taken from Kids Encyclopedia of Animal World. I also decided to make a graph that can clearly emphasize diverse animal stomach capacity, and you can observe the graph. Wonder, what should be a height of storm? The average size of stomach of human is 1 liter. This information was taken from Kids Encyclopedia. The average height of female in USA is 1.65 meters, referred to the 14th citation. Consequently, in order to imagine what the height should be storm based on estimated stomach size, we will make a ratio between these two parameters. Reflecting of a storm height in the proportion of real objects. As you can see, I made this graph to show the comparison between storm calculated size to the scale of real objects. You can look through the graph. Wonder, how much time does Storm spend to eat her lunch? Sure, we have to remember that she is a superwoman, talented in everything and can eat super fast. Current eating record by Takeru Kabashi, the Japanese speed eating demon, 93 burgers in 8 minutes, refer to the citation 15. Hens did 18,141 burgers with a world record speed. Miss Storm should spend 210,889 minutes. It was calculated in the following way: 18,141 multiplied by 93 divided by 8, or 3,514.82 hours, or 146.65 days. 146 days. Non-stop, no sleep, not easy life. And now I'm going to count circumference of the orange by using thread and ruler.
And I went to visit my friend, he left, they told me he just left 20 minutes ago. But then it's raining. No, they made better than before. They would do the thing and create and farm. When did that put me out? 12 hours, 20% of place. Ой, я people think Hello, honey. Some sweet for you.
Wonder, how many oranges can Storm consume by using the size of your stomach? To calculate the volume of orange, we will approximate the shape into a sphere. The volume inside of a sphere, V equal to 4 divided by 3, PR cubed, where V is volume of sphere, R is the radius. In order to work out the radius, we use the formula for the circumstance. The circumstance of any kind, a sphere, L equal to 2πr, where L is the length of circumstance, R is the radius. For my orange, length of circumstance is 26 centimeters length. Then R equal to L divided by 2p. In our case, 26 divided by 2p equal to 4.14. Plus the radius is 4.14 centimeters, which is radius. Then let's peel the orange to make calculations more precise. The thickness of peel is 0.5 centimeters, thus the radius of orange sphere without a peel is 3.64 centimeters, which is 4.14 minus 0.5. So the volume of orange without peel is V equal to 4 multiplied by V multiplied by 3.64 cuboid divided by 3. The net orange equal to 202 centimeters cuboid. Hence, let's assume that the volume of orange without peel is around 202 milliliters or 0.000 meters cubed. Refer to the citation 11. Calculating quantity of oranges Storm is able to consume by using the size of your stomach. If we assume Storm's stomach can roughly include 5,751 liters and the average volume of an orange without peel is 202 milliliters, it presented that 202 milliliters equal to 0.202 liter equal to 0.00002 meters cubed. 5,751 divided by 0.202 equal to 28,470.297. Hence, around 28,470 oranges can fit inside your stomach. In order to count an approximate weight of calculated number of oranges, we have to use the formula of density. As I do not have scale and cannot weigh the mass of one orange, the mass density or density of a material is defined as this mass per unit volume. P equal to M divided by V, where P density of material, M mass or weight, V volume. Hence M equal to P multiplied by V. The density of oranges is defined 1.095 grams or centimeters cubed, refer to the reference 12. 1.095 grams or centimeters cubed equal to 1095 kg meters cubed. The mass density of material varies with temperature and pressure, but variance is typically small for solids and liquids, taking into consideration that the numerical value of density is the same if measurement temperature of water is 4 Celsius. Let's assume that Miss Storm stores the stock of oranges in the refrigerator with 4 Celsius temperature with drying. At any other temperature, the measure of density will be slightly different. Mass orange equal to 1095 multiplied by 0.000202 equal to 0.2212 kg. Then weight of all oranges is around 6,298 kg, which was calculated as 28,470 multiplied by 0.202 0.2212. But one storm meal of oranges could be 6,298 kg. How bad is the mistake? The required volume of storm stomach to be able to consume food for capability of production of a 4-second lightning bolt approximately equal to 5,751 liter. This is 5,751 times bigger than the regular size of stomach of human body, 1 liter. The proportional height of stomach based on your stomach size approximately 9,500 meters. This is 5,278 times higher than the claimed height of Storm, the hero of X-Men movie, referred to as citation second. Certainly from the first glance, it was obvious that the action of Storm, the hero in X-Men, has no connection with reality. By using mathematical methods and logic, we have proved that statement. Definition: degree of accuracy. During my research, I used diverse data displayed in different measurement units. Precision of data is important, however, as many of data our estimates are not precise to the exact figures, it was decided to truncate calculated numbers by rounding them to the different ways. Here you can clearly identify how I used and apply degree of accuracy in my assessment, so have a look through. Additional wonder. This is just an extension for my wonders, so just enjoy it. Let's imagine that all villains were finally defeated by the Lady Storm and her powerful team of X-Men from the Marvel Galaxy. What will happen if we find a way how to utilize hero energy in a peaceful sector? Wonder 2. How can the energy released from one lightning bolt be used? How much power does a single house consume? What does the energy of one lightning bolt mean? How can we utilize that amount of energy? Can that power a house? And if so, for how long? What is the price of this source of energy? What is the average consumption for different countries per house? On this graph you can clearly see household electricity consumption, kilowatts per year, and you can see how much different countries consume. Again, we have to play with averages. Across the countries, household electricity use varies enormously. The average American or Canadian household in 2010 used about 20 times more than the typical Nigerian household, and 2 to 3 times more than a typical European home. Refer to the citation 3 and 4. Calculation residential electricity use. So let's take for our investigation a country from the middle of its range, Germany. According to the survey of clients, Baden-Württemberg der Energie- und Wasserwirtschaft, very difficult. German Energy Company for the year 2010, the average electricity consumption, depending on the number of people in the family, represented by the following figures. Refer to the citation 9. One person, 1,800 kilowatts per year. A family of 2 people, 3,000 kilowatt hours per year. A family of 3 people, 3,900 kilowatt hours per year. A family of 4 people, 4,400 kilowatt hours per year. Here we face the next problem: how to convert kilowatts to joules. We have seen that energy kilowatts equal to power kilowatt multiplied by time hours. Normally we want energy in joules and time in seconds. Refer to the citation 1. The kilowatt above is 1000 joules seconds. The hour is 3600 seconds. So here's the table, how to calculate it. And the final result is 3,600,000 joules. Wonder how many days household could use the energy from one lightning bolt. Let's work out an average consumption of energy per year for different sizes of family in joules, and then the average consumption of energy for these families per day also in joules. Hence, if it's presumed that 4 seconds lightning bolt released 40 billion joules, we'll have the number of days which families can use that energy. That assumes we can catch all of that averages bolts of lighting in a large capacitor. Calculating has been demonstrated in the table below. The calculations imagining of using a 4-second lightning bolt for needs of one peaceful family. So here's the table. Wonder how many days household could use the energy from one lightning bolt. Counting days of using the energy from lightning by household. So I decided for my example to use one person family. So 2253 days means first what we do is 2253 divided by 365 equal to 6.17 years with days. It means that number of days contain this amount of full years. Second, what we do is 2253 minus 6 multiplied by 365 equal to 63 days. So first we figured how many days there are in 6 full years, and then just subtract them from the years with leftover days. Wonder how many days household could use the energy from one lightning bolt. So I also made the same calculations for 2 people, 3 people and 4 people family. For a sharper visual representation, I converted the numbers of days to the number of full years and days. So we figured out that only one session of lightning bolt will be enough to provide with energy a family of 3 people, as mine, for almost 3 years. Whoa, that would be great! Wonder, what is the cost of such type of energy source?
My parents say to me that we pay around 680 for a monthly electricity bill. It means around 28 per day, but our bill for 1040 days will be 20,880.
Taking into consideration that an average price of burger is 20 AD, Mr.'s meal costs 362,820 AD, which is 20 multiplied by 18,141. Yep. So for the service of Lady Storm, we would have to pay 17 times more than we pay currently. Dear Miss Storm, you're immutable, but thank you so much. Keep saving the world. Assumptions. In the purpose to implement my prospecting work on disclosure of movie mistakes, I have committed some assumptions on the following stages: calculating energy of a lightning bolt, calculating volume of Storm's stomach, calculating Storm's height, and on the stage of calculating alternative using of Storm's talent. Limitations were the following: the fact that the source where I was searching data could be not accurate and even incorrect. The level of my current knowledge in physics did not allow me to explain all process in the profound enough way. In the last stage of my assessment task, I also put a bibliography that I used in the task, during the task, and I also collected it in the following table with numbers, link and issue, and some of the bibliography citations I used for my MLA references. Yeah. Thank you for your attention. I enjoyed explaining you my assessment task.